We'll proceed in summation and integral calculus. Okay, summation and integral calculus, we are taking the discussion into, and it is for 2 dimension and 3 dimension summation. That is the point that we are taking into. Okay, before we proceed on the hybrid model of the spherical coordinate system and Cartesian coordinate system, quickly we will have a look quickly we will have a look into the calculating the kind of uh, calculating the volume, that is the 3D, calculating volume of a sphere, sorry, calculating the volume of a cylinder, calculating the volume of a cylinder through cylindrical coordinate system, because it looks highly interesting to proceed with the native coordinate system rather than hybrid coordinate system. What is hybrid coordinate system as far as cylindrical coordinate system is concerned? What is hybrid coordinate system? So as far as cylindrical coordinate system is concerned, the hybrid coordinate, okay, what is cylinder? This is a cylinder. This is typically the bottom surface, a bottom circle, and this is a cylinder. Anyway, I'll take better cylinder. So this is a cylinder. This is a cylinder. And what is the volume of a cylinder? That need to be calculated through summation. Okay, we are pursuing a discussion that through summation can we solve a problem? How to calculate volume of the cylinder through summation? That is the question mark. Volume of a cylinder through summation. If I want volume of a cylinder through summation, then I'm going to cut this cylinder. Okay, first of all, volume of a cylinder through summation, non-vector. We will calculate without any vector fundamental. Non-vector volume of a cylinder, and that is through cylindrical coordinate system. What is cylindrical coordinate system? People, what is cylinder? If this is cylinder and this is the base circle, the cylinder is kept on xy plane. Consider this is xy plane. Okay, I have better xy plane. Consider this is xy plane, and the blue color that is shown here, and this is the center of the xy plane. That is the origin, 0 comma 0 comma 0. Now this cylinder is kept on the xy plane like this. Okay, I want to calculate volume of this cylinder. Okay, if I want to calculate volume of the cylinder, consider there is any point P here. Now the base of cylinder is kept at the xy plane. Consider any point P here. What is the coordinate of point P? Then it is x comma y comma z. This is cylindrical coordinate system. What is the point in? I'm sorry. This is the Cartesian coordinate system, rectangular coordinate system. Okay, what is the point P x comma y comma z in cylindrical coordinate system? That is the question mark in cylindrical coordinate system. What is the point P? If I talk about cylindrical coordinate system, first I need to find three orthogonal components. This is the base of a cylinder and this is the height of a cylinder. We are talking about any point P here. What is the cylindrical coordinate system? Any coordinate system, if I take all the coordinates what we talk in the cylindrical coordinate system, whatever the coordinate we talk in cylindrical coordinate system, if I take any coordinate system, all the coordinates like in Cartesian coordinate system x, y, z, it cut each other at 90 degree. X, Y, Z, it cut each other at 90 degree. Similarly, if I am taking cylindrical coordinate system, whatever the coordinates I take, they must cut each other at 90 degree. Okay, what are the things that I see in cylindrical coordinate system? The obvious thing, if this is a cylinder, if this is a cylinder and this is point P, the obvious thing I see cylinder is the height. This is the obvious thing I see. That is the height. So there is z axis, that is for sure. Because there is a height, height that is a perpendicular height anyone can see. So there is a z axis. What are the two other components that is perpendicular to the z axis? Okay, anyone would say x axis, y axis. Other than x and y axis, are there other lines? But what are the axes? Axis means line. What are the lines that is perpendicular to the z-axis? What are the lines that are perpendicular to the z-axis? That is question mark. Okay, if I take this curve, what I can see? If I can see one surface area like this. How many surfaces I see? The coordinate system starts with the default shape and surface area. Make sense? So, what is the default shape for the cube? If I take Cartesian coordinate system and I have to find all three coordinates of the Cartesian coordinate system, then what is the default shape of the Cartesian coordinate system? Default shape of Cartesian coordinate system is cube. This is the default shape of Cartesian coordinate system. Now tell me, what are the coordinates you see? There are three surfaces, one surface, another surface, and this surface. This surface is parallel to this surface. So there are only three unique surfaces are there, and they are not parallel to each other. This surface, and this surface. This surface I can say this is going along one axis, and I can say it is x-axis. This surface is going along a axis, I can say y-axis. And this surface is going along a axis, I can say z-axis. All three are at 90 degrees. This is the requirement for the coordinate system. All the coordinates must be at 90 degree. If I talk in that manner, then what are the three line I see here? They are at 90 degree to each other. If I say three lines here, then what are the three lines that are at What are the three lines here that are at 90 degree? If I talk here, three lines that are at 90 degree. One line obvious. Now let's see the surface. The way we started our algorithm to compute the coordinate system. If I say that there is something called cylindrical coordinate system. Okay, if I say there is something called cylindrical coordinate system, there is something called cylindrical coordinate system. Can someone tell that what is the sides of cylindrical coordinate system? What is the kind of coordinates of cylindrical coordinate system? What is the coordinate like for Cartesian coordinate? There is x, y, z. Then for cylindrical coordinate system, what it is? Okay, for cylindrical coordinate system, what it is? That is the question mark. Then for cylindrical coordinate system, I have then someone would ask, give me the default shape. Okay, if you want to know the coordinate of cylindrical coordinate system, then give me the default shape of the cylinder. The cylinder is the default shape of cylindrical coordinate system. Now find the three sides of cylindrical coordinate system. There are three surfaces here. One surface is this surface, another surface is this surface, and another surface is this surface. I would rather say there are two surfaces only, this surface and this surface, because this surface and this surface are parallel to each other. Now surface is 2 and I have to find three coordinate system, because if there is a coordinate system in 3D, there has to be three lines they cut each other at 90 degree. Then one is perpendicular, that I see. If I this surface, then one is perpendicular, another is this line. Makes sense? If I had taken, if I had taken, then if this is this surface, if it is this surface, okay, if it is this surface, if I take perpendicular, I'm sorry, let's go with the line. If I take this surface, and this surface I said line is along this surface is line is along this, and for this surface I said line is along this. Anyway, this is how it is, okay? Or someone can say that this surface line is along this. I think this is better. So this surface line is along this. This surface line is along this. Makes sense? This surface line is along this, and this surface line is along this. This is better. So there are three 90-degree lines we have found. Similarly, if I say this, then for this surface, there is one line is like this. There is another line is going like this, rotating like this. Can we see? Okay, are they at perpendicular to each other? Certainly. The arc line, what we are saying, arc line is perpendicular to the vertical line. Anyone can try. Okay, and then there is another surface. At this surface, if I see, then I can see there is a curved line that we talked already, and there is I can see from the center, I can draw a line like this. So this is called radius. Okay, you can draw any number of lines. No one is stopping anyone. Any three line you have to find in a shape. If shape is cylinder, then any three line you have to find. If I am finding any three line, what three line I have found? I have found one vertical line and one arc line, a line that is tangential at any point, arc line, and one line on the top surface circle. From the center, I get another line. Okay, okay, no problem. You can take any line, provided all three must be perpendicular to the each other. Then only I can consider it is ortho. It is a coordinate system, because in coordinate system there should be, if it is 3D, then there should be three lines. They intersect each other at 90 degree, and there cannot be any other three lines that intersect at 90 degree. If I talk about that default shape, if this is the default shape of cylindrical coordinate system, there should not be any other three lines that should intersect at 90 degree. So for to save that, I find the number of unique surfaces. One surface, another surface. In this surface, vertical line and tangential line, and on this surface again tangential line that we found out, and one line coming from the center. This line, if someone sees this line, this line, this line is perpendicular to the arc. If I say this arc is a line, if I say this arc, then this arc is perpendicular to the radius. So certainly they are at 90 degree. This radius like this is perpendicular to the z axis. So radius, z axis and arc, they are at 90 degree. Okay, that is for sure now. Now take the arc, radius and this. If I take the arc, arc, then this line is perpendicular to the arc, because arc is in xy plane, and in that sense this will be always perpendicular to the xy plane. So by default this is perpendicular to the arc in xy plane, guaranteed. This cover the xy plane line circle, then perpendicular will be perpendicular AD point on the xy plane. So it will be perpendicular. In similar fashion, if I have radius, then z will be perpendicular to the radius, because radius is also in the xy plane. Radius and arc are perpendicular to each other. That is for guarantee. If this is the circle and this is the radius, every moment radius and this arc, they will be at perpendicular to each other. Okay, someone is free to prove it. They are at perpendicular to each other. Someone is free to prove it. What is this line? I say my radius is xi plus yj. Xi plus yj, if this is the center, then xi plus yj will pass through like this. If this is xy plane, if this is xy plane and this is the center, then x y plus yj, xi or I plus j, I plus j is a vector that will pass like a radius. Makes sense? This is I, this is j, this is I plus j. What is the kind of uh, this vector? What is this vector? This vector, if I talk how to compute vector, if I have a position vector of any line, if I calculate derivative of the position vector, it gives the tangential vector. What is the position vector of this line? Position vector of this line is xi plus square root of a square minus x square j. Makes sense? Xi plus yj. In that sense, it is xi plus square root of a square minus x square j. Derivative of it, if I calculate, it becomes I plus my plus minus x by square root of a square minus x square j. Let's do dot product of these two. I plus j, that is radius, and that is the circumference vector, that is I plus minus x by square root of a square minus x square. Okay, I believe I believe that this is what it is. Someone can do the dot product of it. Okay, dot product of it will become I here and I there. So it become I dot I 1, and other it will become, okay, it will become minus x by square root of a square minus x square. I believe this is how, okay, somewhere confusion. We will see it later. So how to prove that radius is always perpendicular to the circumference? Any point if I take circumference vector, okay, any point if I take circumference vector, this is also called length vector. Circumference vector is also called length vector. Okay, I'm sorry, I believe I missed something. Okay, what is the position vector? So we'll try again. So if this is circle, if this is circle, then what is the radius vector? Radius vector is position vector. If this is origin and this is the point on the circle, then this is radius vector. Radius vector is connecting origin and point on the circle. Point on the circle is x comma y. That is xi plus yj. That is xi plus square root of a square minus x square j. That is the actual radius vector. And if I do the derivation of that, then that derivation will give the tangential vector, that is I plus minus x by square root of a square minus x square j. Now do the dot product. If someone does the dot product, it becomes xi plus square root of a square minus x square j. Dot product minus dot product I plus minus x by square root of a square minus x square j. If someone does the dot product, it becomes x minus x 0. This is proof that the position vector, that is radius vector, is perpendicular to the circumference anywhere. Okay, understood. Can you prove that it is not the case with everything else? If I consider a line called y equal to x square, there is a line called y equal to x square. Okay, this is a line that is y equal to x square. If it is y equal to x square, and from here to here, if I connect a line like this is the position vector. And if I calculate that differentiation of position vector, then this will be tangent vector. They are at 90 degree to each other or not, that we will calculate. Position vector is xi plus yj, xi plus x square j, because y is x square, xi plus x square j. What is the tangential vector? Differentiation of this, I plus 2xj. Now do the dot product. Xi plus x square j dot product I plus 2xj. It will become x plus 2x to the power 3, I believe so. This is not 0. So not necessarily that every position vector and derivative of position vector, that is that surface line vector, tangential vector, are perpendicular to each other, but it happens in circle somehow. Okay, and for the circle, if someone calculate the take the position vector from origin, then this is radial vector, and if I calculate differentiation, that is the circumference vector, and they are at perpendicular to each other. So when we talk about the three coordinate system, okay, now prove that the z axis is perpendicular to the radial vector. If I take the circle, then it is only in I and j, whereas z vector is k. Dot product will be 0. If I take circumference of the cylindrical surface, that is parallel to xy plane, again it will be in I and j. Dot product with k will be 0. So all three are at 90 degree to each other. So in that fashion, if all three are at 90 degree to each other, then in that fashion we can say that this has three coordinates. One is radius, one is z, and one is circumference vector. What is circumference? If I take any point P here, then in cylindrical coordinate system, what is this point P? Then one coordinate is R, another coordinate is the circumference, because that is the side. Circumference is controlled by, if I move the circumference, Then what is varying? Varying is the angle theta. If we watch closely, if this is the radius, if circumference is moving at this point, then angle, what it is making here, it is changing. So we say circumference, the circumference is not the variable, theta is variable. So if I talk about three variables in cylindrical coordinate system, then it is radius, angle theta, and z. Angle theta, if I take any point P here, then it will be radius, comma, theta. So theta is angle, it should be distance. Because we are taking a coordinate point here, then radius, comma, theta will be represented by r theta. R theta in a sense, if this is circle and this is any axis, from there radius is moving in angle theta. Now angle is 90 degree, 180 degree, 270 degree, and then 360 degree. From here to here, what is the circumference? And if angle is theta, then this theta, the circumference is r into theta. In r into theta in radian, theta in radian. Radius into angle theta is the r. In that fashion, if I talk about any point P here, that is r theta, comma, z. Okay, now we have found that point P, we are in phase of calculating the volume of a cylinder. So to calculate the volume of a cylinder, then I have a cylinder, a real cylinder, and cylinder is kept on XY plane. If I take any point P here, this point is R comma, that is the radius of the top circle or bottom circle. R comma, another is r theta, means if I consider this as x axis, this is y axis, and this is z axis, then from here, if I move little bit angle now, I believe it makes sense, understandable. If this is the circle and this is x axis, this is y axis in Cartesian coordinate system, or I moved here little bit to angle theta, and when I moved it below it, the point P I have taken in that fashion, that angle it moved is theta, then the arc that is the second independent variable, arc is r theta. So any point P here is r, radius from origin, from this point it traveled radius r distance. So r, comma, r theta, comma, from base it traveled z distance. It is here, not at the top, point P. Then at the point P, if I take arbitrarily anywhere in the cylinder, then point P is r comma r theta comma z. Now we are not talking about surface only, okay, because we are trying to calculate volume, right? So if I'm trying to calculate volume, then I can take any point P inside this volume, any point P inside this cylinder, not at the surface, any point uh, inside the cylinder. I consider the radius of the cylinder both sides is a, where if I take any point inside the cylinder and this is the center, if this is the center, then I move radius r. Makes sense? So if this is the circle we are talking about, if this is the circle, if this is the top circle we are talking about, this is the surface of the cylinder. If the top circle we are talking about, this is the center. From center I moved r distance. If I move complete distance, this is the radius of the cylinder, that is a. I move any arbitrary distance r, and then I moved angle theta. I am talking about point here below, and from base I moved z. In that position, that point P we are talking is r, where r is from 0 to a, theta, where theta is 0 to 2 pi, and z is 0 to h. Okay, anyway, we are talking about that point here. Anyway, that is one thing. Now, we are talking about getting the volume of this cylinder through repeated summation. That is the concept, and where there are three independent variables. Let's cut the cylinder into n chops. Now, this is the base circle. Let's cut this circle into n chop. Okay, cut like this, In angular fashion, cut like this. This is the one section, cut in n part. Okay, where the length of one part is r into theta between it. If I cut into n part, then the any side equally, then any length, any section here, if I cut into n part, then any section here, it has an angle. Consider this angle is delta theta I of the ith section. If I cut like this, in this fashion, then this arc length is r into delta theta I. If I cut in n equal part, then delta theta I is 2 pi by n. Next, I believe it is understandable. Then this arc length is 2 pi by n. Okay, for the ith section, whatever it is. Now we are talking about, now I cutting the three coordinates. First I cut the angle in this fashion. Now I have one side here that is cut. Then I cut radius. Radius goes from 0 to a. I cut into n part. Makes sense? And then I have height that goes from 0 to h. I again cut into n part. If I cut like this, then I have a volume inside it. I am dividing this volume, the complete volume, into n to the power 3 parts, where radius angle I have cut into n part, radius I have cut into n part, and height I have cut into n part. Now I have n number of volume inside it that I can see. If I say that if I am cutting the angle in n part, if I address ith part, I'm sorry, if I'm cutting radius in n part, I'm talking about the ith part of the radius. If I'm cutting angle into n part, I'm talking about the jth part of the angle or arc. If I'm cutting the height into n part, I'm talking about the kth part of the z. Now I'm talking about the volume inside it, small volume inside it, that is I comma j comma k. Okay, if I say what is the length of the ith section of this radius? Radius is 0 to a. The length of this ith section, length of this any section is a by n. Length of the arc of radius is 2 pi by n. Length of one section in height is h by n. Make sense? That is the length. If I say from origin, what is the length of the ith section from origin? Then each length is a by n into ith section. That is the length from the origin. If I say in circular fashion, length from the begin point, what is the arc length we are talking in the ith section? Then it is 2 pi by n, 2 pi by n for one section into I. Similarly here for the if I for jth section, for kth section if I say, then it is h by n into k, whatever it is. Now if I take the volume, any I comma j comma kth volume inside, there are n to the power 3 volume I have divided into. Okay, if I say what is the net volume of cylinder, that is summation I equal to 1 to n, summation j equal to 1 to n, summation k equal to 1 to n. Volume of the I comma j comma k section. What is the volume of I comma j comma k section? That is delta r, delta arc, delta z. Okay, now delta r I can say delta ri, ith section. Okay, if I say ijk, that is the point P, from beginning we are talking. If point P is inside it and that point P coincide the ith section of radius, jth section of the arc and kth section of the height, that is point P. Point P lies in the ith, jth, kth volume, whatever it is. What is the volume of the ijk? Now multiplication of three items. This is the kind of they are perpendicular to each other. I can go with the multiplication of this item straightforward. Radius, I'm sorry, radius, arc, and height. You can go with the multiplication of these items, but radius is a straight line, height is a straight line, arc is not a straight line. If it was a straight line, Then you could have gone for a multiplication of three items and it will give the volume. But it is not that. We consider it is a straight line because delta theta j of the ith section is so small, n tends to infinity, that arc is straight line. If that is the way, then delta Ri, ith section of the delta R, into delta arc of the jth section into delta z of the kth section. If I multiply, I get the volume of the ij kth delta V. Now summation I equal to 1 to n, summation j equal to 1 to n, summation k equal to 1 to n. Okay. Now volume of the I, j and kth section, that is delta Ri into delta R theta j, because that jth section arc is delta R theta j into, I'm sorry, R delta theta j into delta z k. Altogether, if I take, it will become R into delta Ri delta theta j delta z k. Okay, this if I see this, then this is transformed into R. R looks like a function over R theta and j. R, and there we have delta R into delta theta delta z, that I can say delta R theta z. More or less, came into a situation, we have function over R theta z into delta R theta z. Okay, summation now, I equal to 1 to n, j equal to 1 to n, k equal to 1 to n. How I can transform into integral calculus? Why you need integral calculus? Because n tends to infinity. If I am calculating volume of I, j and k section, and number of volumes section is n to the power 3, where n tends to infinity, no one can sum it, not possible. So we have to calculate it to integral calculus. To bring into integral calculus, we have seen the fundamental. What is the fundamental to bring into integral calculus? Integral calculus means it will come in a form of fx dx, where x is from one limit to another limit. This is the basic form of integral calculus. Means if this is x-axis and this is origin 0 to alpha, if I break into n section, okay, then each section I call it delta alpha. 0 to alpha, I break into n section where n tends to infinity. Each section width is 0, is delta alpha. Okay, if I take one section at delta alpha at this point, any point inside that I take, then what is the height? This is x-axis and this vertical is function over x-axis. I won't say y-axis, function over x-axis. This is function over x-axis. Now, if I say fx dx, means there is a line like this, that is fx function over x. Fx dx means underneath what is the area from x lower limit to higher limit. That is fx dx. Okay. In that fashion, if I take delta alpha, if I take delta alpha here, if I take delta alpha here, I cut it to n part. If I take any ith part, that is delta alpha, and then I calculate the height, then height will be at this point. This height into delta alpha will give the area of this string. If I add all the area, then I get fx dx from minimum to maximum. So no problem. So what we have now, summation I equal to 1 to n, j equal to 1 to n, k equal to 1 to n. Altogether, I can make it summation something like beta equal to 1 to n to the power 3. Function over theta r and z, that is r, and then delta r theta z. If I say this axis is delta r theta z, the axis name is r theta z. This is function over r theta z. This is what we have. Now, if I divide into n to the power 3 section, n to the power 3, if I take about any section, the width of the section, that is delta r theta z, and height, that is function over delta r theta head, then this is the area of the strip. If I add all the area like this, then I get f function over r theta z into dr theta z as per the fundamental of integral calculus. So I can happily transform. This is a fit candidate because for one section area is function over r theta z and base is delta r theta z. If I multiply like this, then it becomes the area of this strip. If I add all, then it becomes full f r theta z d r theta z, integration from minimum r theta z to maximum r theta z. So we will transform now. Now it is integration minimum r theta z to maximum r theta z, function over r theta z dr theta z. Dr theta z, r theta and z are perpendicular to each other. It will become d theta dr dz, and this will become function over theta rz. If that is like that, integration minimum to maximum of r theta z. R theta z, they can be broken now, and r theta and z, they are at perpendicular to each other. In that unrelated. If this is theta, then progress of this theta in this direction does not hamper or not related to progress of radius in this direction, and they all together, they do not stop any they do not make any relation with the progress of z in this. All three are progressing in orthogonal side. So this integral I can break. Theta is 0 to 2 pi, radius is 0 to a, z is 0 to h, r dr d theta dz. Will it give the volume of a cylinder? Certainly. What is r dr? R square by 2, 0 to a square by 2, I can keep outside. What is z dz? Z integration 0 to h a square by 2. What is d theta? Integration is theta 0 to 2 pi, 2 pi. It will become pi r square h. Volume of a sphere is pi r square h. This is not available in any of the book in pure cylindrical coordinate system. This is pure cylindrical coordinate system. What people would see getting the volume of a cylinder will be in I, j and k vector, I, j and k, where x is r cos theta, y is r sin theta, and z is z. This way they will proceed. We will try that way also. But in pure cylindrical coordinate system, it is I have not seen personally. If anyone see, then it will be rare of the rarest. Anyway, please do not mind supporting us. +91 is the India country code. 9483160610 is the telephone number. +91 is the India country code. 9483160610 is the telephone number.